All right, so 19.3, we're going to start with some vocabulary. Today we're learning about sigma, which is this, which means to add. So if you look at your vocabulary here, this tells you what all of these things are. The index is your variable that you're going to use. This number is your lower limit. This number is your upper limit. And this is called your general term, or your a sub n. To do sigma, you will plug in 1, then you will plug in 2 and 3 until you get to 4. And you will add those terms up. So we'll do that example at the bottom of 303 to show you how it works. Bottom of 303, example A. You're going to plug in 1 to this function. You get 1. Then you're going to plug in 2 to that function. And you're going to plug in 3 to that function. Keep going until you get to 8. Did you guys notice the pattern of it going up by 3 every time? That should happen if it's a linear equation. If my slope is 3, once I start noticing the pattern, I don't actually have to plug it in because I know linear equations go up by a constant amount, and this one is going up by a constant 3. So what this summation is telling me to do is to plug in 1, 2, 3, 4, 5, 6, 7, and plug in 8. When you're done, you add these numbers up, and that's sigma, the sum of the first 8 terms. That gives me 92. We're probably only going to write it out like this for the first one, just so you understand how it works, and that can help you with the more complicated one that we're going to get to in a few minutes. Because this is an arithmetic sequence that has a common difference is linear, we can also do it with what we wrote on our note cards, our formula for S sub n. So I want you guys to do this off to the side, please. Do the same problem without listing out 8 terms and adding up 8 numbers. This formula gives me the same thing. I want the sum of the first 8 terms. N is 8. My first term, plugging in 1 gives me 1. Plugging in 8 gives me 22. I get the same answer. This is how I would like us to do it in the future. Notice it's linear, which means it's arithmetic. And you're summing up a bunch of terms, which is exactly what S sub n means. I've added 2 questions that are not in your notes. You can put these on scratch paper or the margins, whatever you want to, because we don't always start at 1. So I want to show you what that would look like. So anywhere, go ahead and add this problem somewhere, please. My index is n, lower limit 4, upper limit 10, and general rule. By the way, this general rule should always be in parentheses. If it's not, ask me in case I had a typo and forgot to put it in parentheses.
But is this just another way to write it?
Mm-hmm. Sigma is used in many different topics. You remember when we did that expansion thing with the tree? That was adding things. They didn't happen to be arithmetic. So summation was a way to express, hey, we're adding different things. So you'll see summation here and there. Probably seen it in pre-calc. For this case, we're summing arithmetic sequences. So that's why we're using it. Because this doesn't start at 1, we might go through and do it by hand again, which is not the way you would normally do it. But let's do it for this one. So plug in 4, 5, 6, 7, 8, 9, and 10, and then add them up. Again, it has a common difference or slope common difference of 3. So it should be pretty quick to write out those numbers. They add up to 161. Let's talk about doing it with this S sub n formula. What happens here is it's difficult to find the number of terms sometimes, because before it was just the top number. There aren't 10 terms added here, and many people, when they're not thinking, they do this. They do 6 terms. This 10 minus 4 is 6. 1, 2, 3, 4, 5, 6, 7. There's 7 terms. The reason there's 7 is because you're including 4 and you're including 10, which makes 7. So you could always subtract 10 minus 4, but then add 1. You can always subtract, but then add 1. That also works for these. If I subtract 8 minus 1, I get 7, and add 1 more, I get 8. It happens to be the top number if we're going from 1. Does that make sense so far? So we have 7 terms. My first term, just make sure you don't plug in 1. The first term you're supposed to plug in is 4. So plug 4 in. 3 times 4 is 12. 13, 14. This is 8 sub 4. And then plug in your last term, which is 10. 32. That should come out to the same thing. This is the way I would like us to do it. I'm going to give you one more, which you only have to do this way. Questions on this one? I have a question for you. What is wrong with me labeling it like this? S sub 7. Very good. I am adding 7 terms. 1, 2, 3, 4, 5, 6, 7. But S sub 7 usually means I'm adding the first 7. Your book doesn't go through a good way to label this, and so I don't care how you label it. Just don't label it S sub 7. You can leave it blank like this. Just put S sub n. You could do S sub 4 through 10. That's not very technical, but your book hasn't given a technical way to do it, and I don't care. As long as it's not S sub 7, because that's kind of incorrect. So that's how I would do it, S sub 4 through 10. All right, let me give you a new one. You can put this in the margins somewhere. Do not do it the long way. On the test, if you don't want to show any work for a problem like this, I'm okay with that. Just if it's wrong, you won't get any points. If it's right, that's fine with me. So you're looking for three numbers for this formula. How many terms you're adding? If you subtract 25 minus 15, you get 10. Always add 1. So 11 terms are going to be added up. If you have to, use your fingers and count 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. First term means don't plug in 1, plug in our first term, which is 15. That gives me, let's see, 59. Our last term, plug in 25. That gives me 99. For an answer of 869. Sigma. Yes.
Wait, where's that 19?
Plugging in 25.
Oh, 25 and
Yeah, the formula. Yeah. All right, go back to the one that we were doing in your book at the bottom of 303. We're going to do one that your book has, and I'm going to give you one more. Bottom of 303, very last question. Write the sum of the first 10 terms of this sequence using sigma notation. So I'll give you some time to think. You are supposed to write this. That's like your answer for a sequence like that. So give it a try.
How do I draw the E?
Oh, you'll figure it out.
Is it just the E?
It's like a jagged E, and then the bottom sort of has a loop. Yeah, I think the top kind of has a loop, but not going to grade on the E. What?
Here because of
All right, hopefully that first part was easy. We're adding up the first 10 terms. So you can pick any letter here for the index, and then you need 1 through 10. For the general rule, this general rule is A sub n. Your formula for A sub n, A sub 1 plus n minus 1 times d. My first term is 80, n minus 1. My difference is minus 5. So I'm going to distribute that. So 80 minus 5n plus 5 is 85 minus 5n. What I would do is if I create an equation, which sometimes math students are just not great at creating equations, so you could always check it. This is your fourth term. Why not plug in 4 there and see if you get 65? I would always do that on a quiz just to check my equation. Now, this is sort of optional. We know this is linear. We have experience with linear equations. So let's just think about how linear equations work, like this. We know the slope is going down by 5 each time. And B represents our y-intercept. This is our first term, second term, third, fourth. Y-intercept is the 0 term, not the first term over. the 0 term. But if these are going down by 5, we know to go backwards, we're going to go up by 5, which gives me the same thing. I don't care how you find this, but this is sort of a systematic way to do it. You can't do it mentally. Questions? I'll give you one more like this, then I'll give you your homework. Write this down somewhere. Here's your system, and you're going to write me the sigma notation.
How many do we go to?
Just 4, because that's all I have listed. Yeah. Yeah, I'll tell you in words how many, or I'll just list a certain number. So I only have listed 4 terms. That's how I did 1 through 4. I did my formula for finding any term, a sub n. Or you could have looked up here. You are going down by 7. It's linear. That's your slope. So to get to the 0 term, like y-intercept, you'd have to add 7. Puts me at 42. Let me write this the opposite order real fast. Negative 7n plus 42. I want to show you why the parentheses is important. Without the parentheses, technically the thing following the summation is this. So that would be plugging 1, 2, 3, 4 to that. Get that answer, and when you're done with that, add 42 to that. See the difference? So that's why it should always be in parentheses. I know I've made some homework or quizzes before where I forgot the parentheses, but if this is your rule, put it in there so all of this is part of the thing you're subbing into. We do have a short quiz tomorrow. If you know this formula, which is on your paper, and you know this, which we've used several times, and you know how to do summation, you should ace the quiz. That's what the quiz is about. And we've been using all of these every day since. Here's your homework. I'm going to pass back a quiz for you guys to keep. You've already seen it. I just